In this session, we're going to talk about financial models for doing project selection. Remember, I mentioned financial, non-financial. Let's look at the financial models first. It's easier to grasp. So there's a couple ways of doing it. One is called the payback model. And lots of times the boss will say, well, what's the payback? Well, what are they really asking? So measures the time the project will take to recover the project investment. So the usual thought is the faster the better. I'm going to show you that's not always the case, but this is more when they're worried about cash flow. So how fast do I get my money back? So if she comes and says, you got two projects, which ones get me a quicker payback? You can go figure that out. So it's really just the estimated project cost. What are you spending up front versus what are you now going to save per year? So how many years does it take to get back? Okay, and that savings could be a different way of doing it if you're doing sales. How much sales are you going to gain per year, profit per year? So how long does it take to get that back? That's your payback method in years. And usually they're asking in years. The negatives with payback is it ignores the time value of money. $1 today is not the same as $1 in the future with interest rates and growths and things like that. I can invest $1 today and I can make so much money on that, even if it's just the stock market, which averages 7-8%. I can do that with that $1 today, and the payback doesn't account for that unless you get into more complicated payback models. But usually that's not what they're asking. They're just simply asking, how long does it take to pay it back? And it's a good metric as far as cash flow. It assumes the cash inflows for the investment period, does not consider profitability of that and so forth. So let's look at two projects. Project A, investments $700,000, annual savings of $225. Project B, $400,000, annual savings of $110. I can go calculate the payback for both of those. So how long does it take to do this? 225 and 225, 450. Another 225 on the 450, 675. So 3 years doesn't quite get me there. A little bit more than 3.1 years, I get my money back. Here I got 110, 220, 330 the third year, 440 the fourth year. So somewhere between the third and fourth year, my payback's 3.6 years. So this one has a little better payback is period than this one. If I really took into account time value of money at 15% desired rate, and I looked at the rate of return here, which we'll talk about in the future, a couple of slides coming up, this one would have still been better in this particular case from a rate of return also. But it's not always that way. So, but if they're asking strict payback, you get these two numbers here. Okay, that's a quick method to give you a rough ballpark on the two projects. Maybe the boss is really looking to how they push their money around. Let's look at net present value. This is probably the most important one of all of them, though, that makes the sense that most companies use this one or rate of return, which I'll talk about next. So what is net present value? Let's look at the figure first here. What happens is a project typically costs you money up front. In this drawing, I said it's costing me money 2 years. Doesn't have to be, could be all 1 year, could be more than 1 year. It's costing me money. If I take all that cost of money and bring it back to today's dollars with a given interest rate, I've got an expenditure today in today's dollars. That's my net outcome. Next, I want to look at what the project's going to save me or bring in for profits or whatever in the outgoing years after the project's up and running. So let's say I have 4 years that I'm going to get money back from this project. Again, I take each of these cash flows. These are profits. Think of them as profits, these 4 years out here. And I take each of these and I bring them back to today's dollars. What are they worth today? Because dollars out here are not the same as dollars here. So I'm bringing them back to today, today's time zero, before we even start. And I'm looking at that. If the value of that profit, bringing it back now, is more than the cost, I have a good project. Now you say, what interest rate do I do it at? That interest rate is usually defined by your corporation. Your CFO, Chief Financial Officer, will set that rate. If he took the money, or she took the money and put it somewhere else, even if it's just the stock market, they're saying we can make 8%. Or maybe they'll invest it somewhere else and they know they can make a certain percent. Let's just make it round numbers, 10%. So they'll say 10%. They're saying that the project that you're bringing to them has to do better than that 10%, or why do they want your project? So that's why you'll give you a rate and they'll say, show me that your expenditures in today's dollars and your profit in today's dollars, the profit outweighs the expenditures at that given interest rate. Companies will call that the minimum rate of return. They'll call it the hurdle rate, the discount rate. Depending on your company, it's all the same. Saying, what is that rate, and bringing it back. They'll define that. So, but the decision rule's pretty easy. If that project's going to bring you back better than they can do somewhere else, it's a good project. Okay. Now we'll talk about comparing multiple projects in a later lecture, but your specific project, if you brought that forward with this net present value greater than 0, it's a good project. Here it is a little bit more in math terms. And again, we're going to use the minimum rate of return or the discount rate. That's that interest rate. Positive means the project's good. Negative, it's not good. Mathematically, what are we doing? We're taking the funds, the cash flow out here at some time t, and all we're doing is dividing it by 1 plus k. K is that required rate of return, interest rate, to the t power. So if the first year you're bringing it back, you're taking the cash and dividing it by 1 plus k. Second year, you're bringing the cash, dividing it by 1 plus k squared. Third year, the cash, 1 plus k to the cubed. So all you're doing is bringing that back. The 0 year, time now, 1 plus k to the 0 is 1. So I just brought that out front here. That's the initial investment you have out here. So that's all the math is really doing when you do this equation. So here's the nice thing. Excel does it for you. So if you really look at it, it should be cash flows from 0 to n, dividing it by that 1 plus interest rate to the power. Okay, that's the general expression. Excel, it's important, you have to know that Excel will just sum 1 to n. It doesn't sum the cash flow in 0. You have to add that cash flow of 0 on over here. Okay, so you use the Excel value plus this. You'll get some experience trying that on some of the assignments. So, but let's look at it. Let's go look at this type of a project. So the company's saying the discount rate is 10%. You think the project's good for 5 years. You're telling the company that it's $100,000 investment in the project. Okay? You think you can bring in profits in the next 5 years of 10, 15, 20, 30, and 80,000. You think the profits are going to grow over the next few years. So now we go figure out the net present value. So again, we're going to divide by 1 plus I to the n power. N's going to be the year. So I is a negative 100,000 here. Not I. The cash flow, negative 100,000 here. Dividing it by 1 plus I to the 0 power, dividing it by 1. So it costs me $100,000 this year. Next year, I'm going to make 10,000. But remember, money a year from now is not the same as money now. I could have taken some of that money and put it away. So 1 plus I, 1 plus 10, or so it's 1.1 to the 1 power. Divide 10,000 by that. It says that money is only worth $9,000 in today's dollars. Similarly, I'll go to year 2, year 3, year 4, year 5. So this is going to get out here at year 5 divided by 1 plus I to the 5th power. I get 49,000 plus. Add all these up now, 100,000 minus, and all these positives, and I get a positive value, 6678. So it's saying that this project is greater than 0 net present value. It is a good project. I'm making more money with this project than the company can do putting their money somewhere else at 10%. Now, if you were the project person bringing this to me, though, and showing me these numbers, I could say, 10, 15, 20, 30, how did you get to 80 out here in year 5? If I didn't believe that number and said, let's cut it in half, I'd have 10, 15, 20, 30, and now only 40 the last year. Now I calculate the net present value. It comes out negative. Not a good project. I could do better with my money somewhere else. So you, as a project manager, would first need to be bringing this to your supervisor and explaining to her, these are your numbers. If she doesn't believe these original numbers up here and thinks it's more like this, it can sink your project. So you better have darn good rationale of why you think these are the right numbers moving forward. Okay, so this is what's called the net present value method of doing it. This is the easiest and most accurate way of doing that. Again, you'll get this rate from your CFO, then it's easy to do the calculation. The hard part here is I gave you numbers out here. Sometimes it's hard to figure out what those numbers are out here. We'll do an example and I'll show you. Okay, some companies, though, net present value doesn't have as easy or warm feeling as what's called internal rate of return. So a lot of companies like internal rate of return. And they'll have an acceptance criteria on that, okay? And they'll have a minimum rate of return that they'll want. So what is this here? This is the value, it's the interest rate that makes your net present value come out to 0. I'm going to go back a couple slides. Sorry about that, but right here. I am now asking you a little slightly different question. Here, I told you it was 10%, and I'm saying is it positive or negative? For the rate of return, it's going to be a little different. I'm asking you what interest rate makes this green positive part in today's dollars equal the negative part in today's dollars. So what interest rate gives me a wash, makes me break even? That's the rate of return. So I'm asking you what interest rate allows me to break even. So let's go back to here. So if that interest rate is greater than the discount rate, or again, some companies will call it minimum acceptable rate of return, MAR, or hurdle rate, same thing, just figure it out which your company's saying. if that interest rate that makes the cash flows go to zero in today's dollars is greater than their rate of return they're looking for, it's a good project. So if in my example, if it's greater than 10%, it's a good project. So that's what rate of return is asking. Let's look at that. Same problem. I have the two same examples. 10% up here, but we don't care right now. That's the rate I want to beat. We don't use that in the calculations. Now we're going to calculate the internal rate of return, and Excel just has an internal rate of return function that you can use for these numbers, and look at what happens. The rate of return on this project here is almost 12%, better than my 10%. It's a good project. When we calculated the net present value, it was greater than zero. It's a good project. Remember though, I says, well, wait a minute, I don't believe your number out here. It was 80 and I believe 40 is more like a number. Now what's your rate of return? Now look at what happens. 4%. Well, 4% is less than 10. That's not a good project. But the net present value told us that before because it was negative, I think 15,000 or whatever. It was negative, doesn't matter. It wasn't a good project. Either one tells you it's not a good project. Your company might look at net present value, or many companies look at this internal rate of return, or called rate of return. They're both going to give you that same financial information. Good project, changing one lousy number out here, bad project. So again, it's easy to do this calculation. You may have to spend some time rationalizing how you got these numbers. So internal rate of return, or rate of return, is an interest rate percent. It's always between negative 100 and infinity. Infinity is not going to happen, but it could. Minus 100% means you lost everything. Again, that's probably not going to happen, but that's the worst case. In order to do the calculation in Excel, and we're not going to spend a lot of time in this course doing this, but just so you know, this only works on projects that have a negative at the beginning and have a sign change. So you're putting some money out, and then you're bringing some money in later on. But that's most projects. They're costing you something up front, they're bringing you money in later. Even if you're designing a new product, it costs you money to design the new product, and then you're bringing in profits. So generally speaking, this is the way things are. But if you have, say, something that's all positives, well, you can't calculate the internal rate of return because you're not putting any money out. You can still compare those with net present value, or which one's worth more today than the other, but you won't get a rate of return unless you had at least one sign change, some money out versus money in. Let's look at an example. You're in charge of IT. You have 1,000 employees. You're trying to decide if you should upgrade from Windows 8 to Windows 10. Okay, this is probably old news now, but let's say you had to go do that. Cost is $1,000 per person to upgrade. It's going to cost you license costs for the new software. IT is going to have to support some conversion. Maybe you're going to have to train, everybody has to go through an hour of training or whatever. It's going to cost, you figure, $1,000 per person. Is this a good thing to do? Again, I'm looking at this as you have a decision. Sometimes what happens is the customer's going to say, well, we're not supporting Windows 8 anymore, and you have no choice. But I mean, let's say you had a choice. Okay, so let's look at it. So you have 1,000 employees, cost is $1,000 per person. Now you have to kind of go dig for, okay, that's my cost. What's my benefits? And let's just say Windows 10 is more secure, and you're going to save at least one security issue per year. And anytime you have a security spill, it's a lot of dollars to fix it. So let's say it cost you on average $100,000 per security issue. but you're going to save one a year because you're going to a more secure system. Okay, maybe Windows 10 is a little bit more efficient than Windows 8, and over the course of a year, you're going to save 10 hours of efficiency per employee. Remember, that's not a lot. 10 hours out of a typical year is 2,000 hours, but you're saving maybe a few hours over the year. And average for employees, $50 an hour rate, let's say, which is not unrealistic when you're talking benefits and everything else. Okay, so now I have some dollars in. Here's my dollars out, $1,000 per person. What's it bringing me in? Now let's do the math. $1 million out. I just took 1,000 times 1,000 employees because I said we had 1,000 employees and it was $1,000 per person. So $1 million out to do the upgrade. I'm assuming we're doing it all 1 year. This could spread out over years, but let's just say it's 1 year. And I'm saving security each year of $100,000 over the next 5 years. I'm only doing it over 5 years because after that, maybe there's going to be Windows 11, whatever. So if I bring that in, look at what happens. That savings in today's dollars doesn't offset the cost of upgrading to Windows 10. It's negative dollars. I am losing money by doing that upgrade and only saving one security issue per year. Now again, you may have saved more security issues or whatever, but these are the data we had. Now, though, let's add in not only my security issue of $100,000 a year, but I'm saving 10 hours per employee. Remember, 10 hours out of 2,000, it's not a lot, but I'm saving 10 per employee in efficiency. So I'm saving $500,000 a year now in efficiency. So my savings per year now is $600,000 a year. Now if I take that and add it up, it's a good project. That savings over the next 5 years between security and efficiency is outweighing the cost of my upgrade. So now I've got a net present value greater than 0. It's a good project. Okay, so that's how these work. Sometimes it's hard to figure out what these savings really are. It's usually pretty easy to figure out what's the cost of an upgrade. What does the savings really do for you? Here could be a different example. I'm not going to go through it, but let's say you had this example from the boss. Should you invest in a new test chamber? Why I say invest, you buy it, versus should you rent a test chamber? If you own it, it's cheaper cost per hour than renting. Okay? So, but you have to put that money out to buy it, because when you rent, they're usually going to charge you more for the rentals and maintenance and so forth. Having the chamber might help you with called P-win, probability of win for contracts. You can now tell customers, I have this new test chamber that's going to help your project, and it might help you. Would you be willing to pay for this test chamber? Again, it's easy to figure out the cost. What would be the savings is what you would have to go figure out and trade that off, buying the test equipment and savings versus renting. Might be another example that you'd have to go through. Okay, so financially, easy to make financial decisions on a specific project. Later lecture, I'll talk about comparing multiple